What's going on, everybody? Jesse here, and welcome back to another episode in the Blueprints to C++ tutorial series. In today's episode, we are going to implement the vision of the character so that we can begin seeing the objects in the world. So sit back, relax, and enjoy. All right, so we're over here in the first person, the true FP player character here, and I want to explain something here. So with our vision controller, with our vision trace, what we're doing is in the player character in the begin play, we're setting a timer here to vision trace, which is the function that does all of our tracing for us. And then inside the vision trace, we come in here, you can see we're just running a basic line trace here. We're getting the follow camera, getting the world location, rotation, forward vector, all that good stuff with the vision distance. Coming in here, checking the hit actor. We're making sure it's not equal to the vision actor variable. If it is, we're doing various things in here. Come down here, make sure it's valid. If it is valid, then we're going to run this code. If not, we're going to run this code. But ultimately, we're setting the set look at here from the vision trace of the hit actor, which is the interface call that we created in the last episode. And so we're not going to set this here again in this episode, but we're going to get this vision trace going. But one of the changes I'm doing with this is, like I said, this is on the character blueprint here in the original project, but I'm going to go ahead and take this and we're going to put it inside of the inventory. And that's not probably the best place for it because, you know, if you're trying to think of polymorphism and things like that, you should just kind of have things where they should be. But I think the vision trace is important enough to the inventory that I want it to be part of the plugin, right? I don't want to rely on whoever may be using this plugin down the road to have to all of a sudden code their own vision trace and follow a bunch of rules and guidelines in order to get my inventory to work with it. So we're going to make some features to be able to shut it off so you can override it if you want to. We're going to do that. We're going to put it inside of our inventory component. And so let's go ahead and jump over into C++ and let's get this coding. So as I mentioned, there are various options I considered before putting it into the inventory component. I considered making the character part of the plugin, but that was unnecessary. It's just too big to need to put in with the plugin. I thought about making a separate component, but then it's just a component that's just going to run a simple couple of functions. And so, yeah, I'm just gonna put it in here. It may be a little sloppy, but ultimately I'm not too concerned about that. It's gonna do what we need it to do. All right, so let's go ahead and create some of our properties. First one, we're gonna do a bool, and all this is within the private specifier here in the inventory component.h. We're gonna do a bool b use default vision, and this is gonna give us the opportunity to disable this vision if we want to implement it a different way within Blueprints or even another C++ class. This is going to give that, but I'm going to default it to true because by default I want this to be active. Then we're going to do an F timer handle, and I'm going to call this vision timer. If you remember back in the vision timer handle, if you remember back in the blueprint when we started in the player character before the function, we were saving the handle of the timer function. That's all this is right here. Next, let's give it a float vision delay, and I'm going to default it to 0.1 F, which is 10% of a second. And let's go ahead and do another float. We'll call this one vision distance, and I'm going to default it to 350 F. Next up is a bool. We'll call this b use vision debug. So now we can toggle this. We'll use this to decide if we want to put our vision into debug mode. And I'm going to do a default of false. Next up will be another float, and vision debug length equals 1.f. This is how long you want the debug line to stay on the screen. And lastly, let's go T object pointer. It's going to be an A actor, and we're going to call this vision actor, and I'm going to set a default to null pointer. So now I'm going to copy and paste a comment in here for the default B use default vision trace. And there's my comment. If you want to implement your own trace elsewhere, turn this false. If moving trace to different actor, you will need to create a setter function for vision actor and update it when you see an object. Failure to do so will remove item interaction. And then another thing I want to do, I'm going to do it right above this comment, is I'm going to add a couple of lines of comment here, and I'm going to go vision. So that way I know that our vision variables are all within this little scope right here. I'm going to come down here and I'm going to go end vision. That way I just kind of know that all this is part of our vision. So let's go ahead and set some view properties. This first one, we'll just go edit defaults only, category equal to inventory vision. And I'm going to copy this and come down here and let's go U property. And actually the timer, we don't have a U property for a timer. Come back down here again, U property vision delay is going to be an edit defaults only, and then a category of inventory and vision. And I want to set a meta equal clamp min equals 0.f. I don't want the user when setting this to go any less than 0. Then come down here, set another U property. Vision distance, I'm going to make this one blueprint read write. Give it a category of inventory and vision. And I'm going to give this one a meta of allow private access equals true. And the reason why I'm giving this one read write, I originally had it when I was designing this as edit defaults only, but perhaps there's something in code that you may want to alter this. I don't know, maybe the character gets intoxicated or gets poisoned by something, and you want to alter this. This gives you the ability to do that within code, so or within Blueprint. So I'm just going to make that blueprint read and write. You could probably set a minimum and a maximum to this as well, so just keep that in mind. But you can do that up there just like we did with the vision delay specifier in the properties up there. All right, and then I'm just going to copy this U property here. I'm going to come down here to the use vision debug, and I'm going to only change I'm going to make is I'm going to add another pipe here and go debug, and then I'll copy this one and I'm going to set this as the debug for, or the property for the vision debug length. Then lastly, for the object pointer, we're going to go U property blueprint read only, category of inventory and vision with a meta of allow private access equal to true. Remember, anytime we're in the private section and you have a U property that is blueprint anything, you have to make it allow private access true. Otherwise, you're going to get errors. All right, let's go down to the functions now, and these are going to be protected functions. So just like I did up there, just so I have a little bit of sign, there's only a couple functions here, but I'm going to go vision. And there we go. I know I'm in the vision section here. And it's just going to be easier to find this if I'm trying to debug something with vision when I have everything inside this, because the inventory component is going to be a pretty big class. So if I'm trying to find it, then I can come in here and easily find it within the code comments, or the comment structure here. So this first one is going to be a void vision update, no parameters. Next one is going to be void vision trace, and this is going to be F hit result, and it's going to be passed by reference, and we're going to call it trace hit result. And then now let's give this a U function, and this is going to be a blueprint native event, category of inventory vision. All right, so yeah, this is going to be a blueprint native event, so we can create the default C++, what we want the vision trace to do here. And if you do want to override this class, you're more than welcome to override this in blueprints. So that's what I'm doing right here, is just defaulting this. We don't want to make this blueprint callable or anything, because this doesn't need to be called there. If you're overriding it in C++, and you'll be able to grab it and use it there. But right now, just blueprint native event. And now if I right click one of these and go generate definitions, select these and select OK, I now have my definitions. All right, so now before we build these definitions, I do want to come back here. We're going to start in the begin play, but what I want to do is I'm going to come back in here to the header file and come up here into our properties, and we've got character here. For one, I want to change this to a T object pointer, and it's going to be of a character type, and we keep it with the name character and null pointer. And one other thing I want to do with this is I actually want to make this inline, and I want to make it static. And when I do that, you're going to see here it says that I cannot mark it as U property. So I'm going to go ahead and delete the U property here. So now what is inline and static? Well, they're two separate keywords that we can join together here. So a static variable means that only one instance of the variable is shared among every instance of the class or function. That means that it persists across multiple calls or instances. So if we have different children of this, if we have these objects all throughout the world, let's say all our storage inventories and things like that, they're not going to have their own character. It's going to share the same thing because it's static. All right. So when a function or variable is considered inline, essentially what it does is it tells the compiler that instead of generating the function or variable, what it's doing is it's generally just putting this directly into the code. It's injecting the whole process into the code. So instead of making a call back to this to do it, it's just when we call character in our C++, it's going to inject the code that it takes to get this character. But again, it's only going to get it once. We're only going to have this variable called once, and it's going to be shared amongst all instances of the inventory component. Okay, hopefully that makes a little bit of sense. So let's head back over to the inventory component. And now in the begin play, we're going to go ahead and define this character. So right below set up inventory struct, I'm going to go character, and this is going to be equal to u gameplay statics, and it added the include for me automatically. And I'm going to go get player character, and we will go get world, and we want to get world of player 0. So again, u gameplay statics, get player character, and then when we get the player character in this method, it asks for a world context object, so we get the world, and then it asks for the player index, so we're just getting the first player in the world. Since this isn't multiplayer or split screen or co-op or anything like that, player 0 is going to return the only player in the world. So now let's go down, and now let's start the vision timer, and with this we'll go if character and B use default vision and character is equal to this get owner. So ultimately what we're doing is we need to check these three variables before we go any further into this code. So do we have an active character? True. Are we set to default vision? True. And is a character equal to this being the inventory component, the owner of this inventory component? In other words, this isn't going to run in begin play when it's a storage unit. So whoever owns this inventory must equal this character class, because we don't want to run vision trace on storage unit, right? That's kind of waste of processing power. So you see here, we've got our double equal is red squiggly line, and it's telling us that we can't call this operator in this function. So we can actually, but what we need to do, and this doesn't add it for me. If you come over here, you can see it doesn't give me any options here in the error side. Generally, what this means is I just need to add the character. We need to include the character header here. So I'm going to go hashtag include game framework / character.h. And there we go. It gets rid of the equal signs for us. And now we don't have any errors. So let's go ahead and continue this function. If all this is true, then we want to get the character, and we want to get the world timer manager, and we want to set a timer. And inside these parentheses, I'm just going to hit enter, and I'm going to split the parentheses so that way it's a little easier for you to see, and even for myself to see in the code. Sometimes it's easier when you got long lines of parameters that you're setting, that you have them just kind of in a vertical line. So first we need to give it a handle. We created that handle. We called it vision timer handle. All right, so this is where it's going to be stored. Next, we need to give it the delegate, which is going to be this. All right, so if the delegate was on, say, your player controller, then you would add your reference to the player controller there. But because we're going to call a function on this inventory component, we're going to put this here. All right, so with this, now we need to identify the function that we're going to call with this delegate. So we're going to go u inventory component vision update. Select that and then add a comma. Next line, this is going to be the in rate, which is the how long it takes for this function to be called, which is going to be the vision delay. And then lastly, is this looping? Does it loop? Yes or no? We want this to loop because it's our vision. So enter true, and there we go. And I'm going to finish this off. And we now have a world timer set to call our function visit update every vision delay, which we have set to a 10% of a second. So one at every about, if you're getting 120 frames, that's once every 12 ticks, right? So that's good. We relieved the tick just by a little bit by running this function here, and it seems to work pretty good. So now let's go ahead and update the vision update function. So let's go ahead and create a local variable. I'm going to call this f hit result, and I'm going to give it the name hit result. And then with this, we're going to call vision trace. We already created this function here. We want to call the implementation right here. We're going to call this vision trace implementation. Next, we need to call vision trace, and we're just going to call this. You don't have to call it implementation. It doesn't matter. It's going to call the implementation no matter what, but we're going to call vision trace. And in here, we need to give it the hit results. It's asking for hit results. So if you're unaware how this works, if we come back here and we look at vision trace, when you look at the parameters here, we have f hit results, and it's being passed by reference, and we're calling it here in this function. It's going to be using this function as trace hit results, but we're passing it in by reference. So what that means is we're up here when we call the function, we're passing our local variable in. And when it calls this function, it's going to take this variable that's passing in, use it, fill it full of information, and then once it breaks out of that function, it's going to come back into our vision update and have all the information we need, like what you would expect a normal hit result has, right? So passing by reference, that's what we're doing here. We're just sending it into this function to get all the information we need, and then we're going to execute on that function there. All right. So with that, now there's a couple things that we're going to do that I'm doing a little bit differently in this one. I kind of mentioned it in the last one. Last episode is I'm putting a widget component on the world object, so that way when you look at it, it has a little pop-up widget on there that gives you some information. Previously, I had it display in the player HUD, and you can still do that. I'm going to put the code in here still, just in case you want to do the HUD. If you could put it in this way, even if you're going to do the widget component like I am, and having this code in here isn't going to hurt anything. It's not going to add much to the project or anything like that. But if you want to, if you know what you're going to do, come back and delete the aspects that we don't need. Otherwise, I'm just going to put it in here, but I'm still going to end up using the component. And as we get through, I'll explain what you'll need to do if you do want to keep that in the player HUD instead of on a widget component on the world object. Okay. So we need to get the f text, make an f text. This is a local variable. We'll call it interact text. And I want to set some defaults to this. The way you set a default to an f text is we go f text, and we're going to call the static function get empty. All right. This allows you to set your f text as an empty variable. We want to ensure that this is empty. We need to instantiate this in order to use it down the road. If it's empty, right? We're going to know if it's empty or not. So we're going to make that check. So this allows it to actually be empty. And then same thing, we're going to do kind of the same thing with an f name. We're going to call it name, but instead of what we did up top, we're going to go name in all caps. This is going to call a macro, and we're going to choose none. So name underscore none. And again, if we're not going to do the inventory or if we're not going to do the pop-up text on the HUD instead of the widget component, then we really don't need that interact text. We'll have to change some functionality with our set look at actor as well if you're not going to do that, but I'll explain it more as we get closer to it. So next, let's go if the hit result dot is valid blocking hit. So if we do have a valid blocking hit, we want to go if hit result dot get actor and hit result dot get actor implements you interact. So we want to ensure that we are actually hitting an actor, valid blocking hit, it's an actor, and that actor implements our interface. So we only want to do any of this, right? Our ultimate goal of this is really to be able to interact with the object as well as display the set look at little lines that we have around there, the trace around the item. And so with those, anything we want to interact with implements this interface, which right at this point is just the world object and will be the storage down the road. So anything that has interact is going to pass for this and run this code in here. Okay, so if it does, if this is true, let's go. If we are hitting the same actor, then simply return out of the function. So we're going to go if hit result dot get actor is equal to vision actor. So if these two are the same, then we simply want to get out of this function, right? So we're looking at the same object. We don't want to keep updating it if it's the same object. So I'm just going to go return, and I'm just going to keep it in line like that. All right, next up. So if we do hit an actor, but it's different than the one we saw the last update. All right, so we need to check, do we currently have an valid actor. So if is valid vision actor, then we come out here. And now let me show you in blueprints real quick, just remind you where we're at here. So if is valid vision actor. So jump back into blueprints here. And so now what we're doing is we're actually checking here. We're actually in this code. We've already, even though we haven't written the code yet, we've written in this particular update, we're expecting that we already have done this trace, right? So that's why we broke it down into two different functions. So we can call this, but we can continue writing this function, even though we haven't actually written this code yet. We'll write this code in a minute. But we're here, we're checking, is the hit actor the same as the vision actor? If we are, then we don't want to do anything. If they're exact same, we just wrote this one, we don't want to do anything. But if they're not the same, then we want to check, is vision actor valid? If it is valid, then we want to come up here and set all this code. We want to set the look at, we want to reset the vision actor, and then we want to come up here and do another validation here and check set look at here. So essentially this is taking the old vision actor, removing the set look at from this, resetting the vision actor, making sure that it's still a valid object here. And if it is, then we want to go is looking at true, right? And the reason why we run this check here is because since we're only running the vision update every 12 frames or so, every 10th of a second, we need to ensure that we didn't quickly move the mouse and do this. If we did, then we need to reset out of here. We need to simply return here. These are the checks we're at right now. So right now we're at this aspect of it. So head back over to C++ side. All right. So if it is valid, then again, we need to reset the vision, the set look at of the current vision actor, not the one we're looking at, but the one that exists in the variable. So the way you make an interface call is we go iInteract, right? This is the interface that we have, iInteract. We need to do a static call, and we need to go execute set look at. So when we call this one, we're going to go vision actor. We want to call this on the vision actor, and then we are setting its variable here. If you look up there in the top, we set the object. Now we're setting a const bool b is looking at. So we want to clear this one. So we go false. And the next section is the f text interact text and the f name name. Now you can see there in the pop-up, it shows that it's being passed by reference. So we can pass it in here in the set look at and return the interact text and the name back into here. So by doing this, it's going to actually populate the interact text and the f name for us. So we're going to pass in the interact text and the name. And again, if this isn't something you want, if you know for a fact you just want to continue without having this show up in the HUD and just using the widget component, then rewrite the set look at interface call to remove the interact text and the name. But again, having this, you can leave this in, and if you want to switch back at any point, then you can. You'll just have to come back and handle, because I'm not going to handle this for the HUD class. That's pretty self-explanatory. I'm going to keep it as an inventory component, but I'm going to keep the code here just in case if at some point I decide to come back, then I can do that there. All right. And then simply when we're done with that, we want to go ahead and return. And then after we're done doing that, we want to go ahead and set the new vision actor equals hit result dot get actor. And then now we need to check if is valid vision actor. So this is that final check I said, in case since we're only looking at every 10th of a second, if we happen to switch so fast that this function doesn't update properly, we need to ensure that we still have a valid vision actor. And if we do, then we need to go iInteract, execute, set look at, vision actor, true, interact text, and name. And then from here, we will go ahead and type in a return. And there we go. So that's the end of that branch. So now we need to go ahead and it graded out here because it says it doesn't need it, but that's just because we haven't wrote the code below this yet. So with that, now we just need to come down here and we need to type in, this is going to be for the if is valid vision actor. What happens if this isn't true? If this isn't true, then we need to return. And I'm going to put a comment in here because technically, if we reach this stage, then there's a bug somewhere, really. If at a bare minimum, then you need to probably update the speed of your timer, or perhaps you're lagging too much to be able to get this to function properly. And if that's the case, you need to make some adjustments. All right. So again, not a good vision actor. If this line is reached, then there is an error and it should be handled. Right. So really, you could probably put a check in here, do a checksum and crash the game if this doesn't happen. But I'm not going to do that. We're just going to return out of this and the vision trace is going to fail at that point. So you'll notice some bugs in there if that is the case. So now out of this if, we need to come up here now, and we're still within this if right here. So you can do that. You can see we're highlighted, so we're still within that. And we need to go vision actor equals hit results dot get actor. So what this part is if we don't have something in here, right? So our vision actor is currently empty, then we're just going to set it with the hit results of here. Right. So we don't need to clear the set look at of an existing object within our vision actor. We're just going to populate it with a vision actor. And then from here, we'll do like what we did before. Go interact, set look at, execute set look at, vision actor, true, interact text, and name. And then from here, we'll return. And then now we'll come down here and we'll finish this up. So this is if we have no valid blocking hit, we need to reset the set look at if there's still a valid visible vision actor. So we go if is valid, and we want to check is the vision actor still valid. If there is at this point, then we need to go interact, execute, set look at, vision actor, false, interact text, and name. And then we want to take the vision actor and set it to null pointer. And there we go. No need to set a return here because that's the end of the function. So this again is if you're looking at an object, then you look away and there is no current vision actor. We need to set the vision actor to false, to set look at to false, and then reset the variable to nothing in there. And then that's it for that one. So let's go ahead and work on the vision trace implementation next. All right, so this one's going to be a little bit more involved. I'm going to do my best that I can to kind of explain what is going on here, but it's not going to be too bad. There's just going to be a whole lot going on in order to do this vision trace. All right, so the way I'm going to do the vision trace in the blueprints, what I did was I did the follow camera. I don't like that. I didn't like doing that, and you can do that because the way we're doing it is we're going to deproject the screen to the world, and we're going to get the position of the screen in the world, and we're going to project from there. It's a little bit more costly, and so if you run into issues, you can come back and rewrite this vision trace code to go from something like the camera. Main reason why I'm not doing that is because, the camera sits behind the capsule, and then so now you got to figure out how big the there's just a little bit more to it that way. It's not that big of a deal, but you can do it if you want to. Just keep that in mind, okay? So it's a little bit different way we're going to do it here. So let's go F vector 2D, and I don't know what the lowercase is here. If you see that in yours, I would think it's the same, but I stick with the 2D capital here just in case. And I'm going to call this one viewport size. Then I'm going to go if G engine. We want to make sure we have the engine running. If we don't have the engine running, we got bigger issues, but we still need to check it. It's always good to double check everything. And G engine game viewport. And then with that, if we have the G engine and the game viewport, then we want to go G engine game viewport get viewport size, and we want to pass in the viewport size variable that we just created and terminate it there. So again, if you look here and hover over get viewport size, you're going to see the parameters for the function. We are passing in by reference a viewport size variable in F vector 2D, and we created that, the F vector 2D viewport size, and so that's what we're passing in right there. Okay, and then it's going to go ahead and take the information when running this function, and it's going to put it inside of our variable there so that we could use it here later down the function. So with that, now I'm going to make a const F vector 2D, and I'm going to call this center vision location. And this would be the same thing as going equals and then going center vision location and setting the parameters here. But we're just going to come in here, since it's a 2D, we can set its parameters here instead of hitting equal again. We're just going to set it like this. So we go viewport size dot X, and I want to divide it by a float of 2.f, and then on the y value, I want to go viewport size dot y and divide that by 2.f, and there we go. So you can see here, it's got the parentheses in blue. That's because we're setting the default values of this center vision location. So every time this function is called, we're resetting it with this. And if you don't understand why we're doing divided by 2, is because it's giving us the full size of the screen. So, 1920 by 1080 or whatever it is. And so we want each of those, the X and the Y, divided by 2. So that way, no matter how big our screen size is, it's going to find the dead center of our screen. Now let's go F vector. This is just going to be a regular F vector. I'm going to call this one vision world position. Then we're going to do another F vector. I'm going to call this one vision world direction. Okay. And again, these are going to be passed in as by reference. So they're going to be populated in the deproject world function that we're going to call here in just a second. So now let's go bool b screen to world, and we could put this, we're going to use this in a minute. You're going to see it's going to give me a green squiggly line. We can run this as an if statement. I'm just not going to, because it's a little more clear of our intent when we're doing this. So we're going to get bool b screen to world, and we're going to go u gameplay statics. We're going to call the function deproject screen to world, and with this one, I'm just going to separate the lines here. I'm going to put this on their own line. So the first parameter, we're going to go u gameplay statics, and we're going to get the player controller, get world, and player controller 0. For the next parameter, we need an F vector 2D for the screen position. So this is going to be our center vision location. And then the next one is going to be a world position. You can see there it's an F vector and it's being passed by reference. So the world position. So we will pass in the vision world position, and then the next parameter is going to be an F vector called world direction. So we're going to pass in our vision world direction, and there we go. Now we got that set. So let's go if b screen to world. So with this, now we need an F vector, another F vector here. I'm going to call this the start location. Now this is going to be some of the familiar stuff that you're used to when you're running a line trace. We need a start location, and the start location is going to be the vision world position. And then before I write this next line, one variable I forgot to do, I'm going to head back out here into the header, and in the properties inside of our vision section here, I'm going to go above the debug, and I'm going to create a new variable. I'm going to make it a float. We'll call it vision distance offset, and I'm going to give it a default value of, let's say, 10.f, make it a U property, edit defaults only, category, inventory, vision. And I'm going to give this a meta equal to clamp min equals 0.f. And then let's head back into the source file. And what that's going to do, the code we're going to end up running, it's going to project it right on the outside of the capsule, which is fine. We're going to tell it to ignore the player, but in case you want to start it out by just a little bit. So I'm going to do that with the 10, and you can adjust that if you need to, or like I said, have a 0 if you want. You don't want to go any less. That's why we put the clamp there. So with that, I'm just going to go start location plus equals. So we're going to take the start location, we're going to add a value to it. We're going to get the vision world direction, which essentially is just the normalized variable of the current direction we're facing. And then we're going to multiply it by the vision distance offset. Now let's go const F vector end location, and that's going to equal the start location plus the vision world direction multiplied by the vision distance. So if we go back into blueprints, I'll show you exactly what we were doing. So here in the vision trace function, come in here. So again, we're plugging in the start and the end. So our end is taking the vision distance. So the 350 centimeters that we have here is default. Now, again, this isn't set up to what we currently have, because we're going to end up deleting this, right? We're putting everything on the inventory component, but this is essentially what we're doing. We're getting the vision distance, multiplying it by the forward vector, which is our world direction, world position direction that we put in there, adding it to the start location, and that becomes our end location. One thing I am going to put in here is right here, we've got actors to ignore. I'm going to add the character in here. We're going to create a collision parameter, and we're going to ignore the character. So we're going to add that. But other than that, this is essentially what we're doing here when we call the license trace. So everything we've done is just to get this information before, in order for us to call this function here. So let's head back to C++. Okay, so now that we have that end location, let's go ahead and set the collision parameter. So we're going to create a new local variable. I'm going to call this one F collision query params. I'm going to call this one collision params. And then we're going to go collision params dot add ignored actor, and we're going to put in the character, and there we go. So now we're going to ignore the character. You can add other parameters that you want to this. There's quite a few parameters. So if we come down here and we go collision params dot, and you're going to get a list of all the different parameters that you can add here that's going to add it to the line trace. So if there's stuff you want to do, scroll through here, take a look at it. Pretty much everything from this point up is things that you really want to work with, not these ones down into here. But yeah, everything up here is what you have access to. I'm not going to add any more for this particular line trace. So now let's go ahead and call the actual line trace function. So we go get world. With the get world, now that we have the world, we want to go line trace single by channel. And again, I'm going to split up the parameters right here. So first thing we need is we need an F hit result called out hit. So we're going to pass in the trace hit results that we are passing in at the start of the function. Next up, we need a start location. So let's go start location. We need an end location. So let's go end location. Now we need a trace channel. So we're going to go ECC. Now what ECC stands for, E stands for an enumerator. C stands for collision channel. Underscore visibility, ECC underscore visibility is a channel we're going to use for this particular one. And then the last one is we are going to pass in our parameters. And this one, if you look up in the little help box into here, you can see that it has an equal sign. So it's already set to default query parameters. So because it's already set to an equal value, you can ignore this. If you don't have any collision parameters, you don't need to do this at all, and you don't need to add anything right here. You can be done with the function. It's just going to give it the default query parameters. But we do have some I want to pass in. So I'm going to go collision params, and then that's it. So now that's calling our line trace by channel. So now let's go ahead and work on our debug stuff. So if we come down, now that we finished that, we go if b use vision debug. If that's true, I want to give it a const f color, and I'm going to call it debug color, and it's going to equal trace hit results dot get actor and trace hit result dot get actor implements you interact. Now, if you don't know what I'm doing here, you're like, what are you doing? You're setting a local variable f color. There is no color in here. Well, true, but you can set, I think it's called tertiary operators within here. So we're essentially running an if in the operator here. So what we're going to do now is, now that if these conditions are met, if it's a trace result hit actor, if we got a hit actor and that hit actor implements you interact, what we need to do now, and you could do this all in line, but I'm going to do this again. I'm going to break up the parameters here. I'm going to hit enter, put in a question mark. So if this is true, we want to make the F color green, and then I'm going to hit enter again. So it's on a separate line, and we're going to put in a colon, F color red, and there we go. That's it. So again, the debug color, if our trace result has a hit actor and that hit actor implements you interact, then we want to give it a debug line of green because we're in use vision trace. So we want to give it a color of green. If not, then it's going to be red. And then now we need to draw the debug line. So go draw debug line, and we go get world. Next, we need to give it a start location. So we go start location. We need to give it an end location or a line end. So we go line end location. It needs a color. So we'll give it our debug color. Now it needs to know, are the lines persistent? It's going to default to false. You can leave pretty much the rest of this blank if you want to. It'll just have a default value here, but we need to give it a persistent line. I'm going to say false. It is not persistent. And even though it's default there, because I want to change the last parameter, I have to give it a value here. You can't skip this and just enter the last value. You have to put something here, even if it's the same as the default. So we go false. And then the last one I want to do is the vision debug length. So this is how long the line is displayed, what its lifetime is. And then that's it. So now let's go ahead and build it and make sure everything builds just fine. All right. And you can see right here, unable to build while live coding is active. Exit the editor in game and try it again. So let me exit the editor and let's try it again. This time I'm just going to hit the play button because it will build and launch the editor, because we want to go back in now and we want to test this all. There you go. Build succeeded. So let's open up the editor. All right. Now that with the editor open, I'm going to head back to the true first person, and I'm going to come in here into the event graph. And right here where we set the set timer function we're calling the vision trace, I want to skip over that. So these two nodes right here, I want to skip over. So I'm just going to take this, I'm going to plug it straight into the HUD because we still need to call the HUD right now. We haven't taken care of any of this, but all this right here, that's pretty much going to be dead, including this vision trace here, but this isn't going to be called. So what we need to do now is select our inventory component, right? This is the C++ version of it. This isn't a blueprint. This is what we've been working on. So if we select this now, come over here to inventory, we got our new vision tab, come down here, use default vision. It's set to true. We can change these values. Here's our debug, just so we know we are using it. I'm going to enable debug mode and leave that as a default of 1. So we'll get 10 per second. Let's compile it. So now we should be bypassing this original vision trace and enabling our new one. So hit play and let's check this out. I'm going to actually go out here to the map because I'm going to eject. So press play. And you can already see some red lines there. So come up here. Now these do have the interact, but it's not the C++ interact. So we're going to be able to do these world objects probably in the next video. I was hoping to get it done in this one. But yeah, this vision trace was a little bit more complex, took a little bit more time. So now if I shift F1 and I exit out of here and eject from the player and fix my camera speed, you can see here is the vision trace, right? It's coming straight out from pretty much where the player's eyes is. So that's great. That's generally where we have the camera, right? If we were to show the camera, you'd be able, if we made it visible, you'd be able to see it's essentially just going from right there. But if I enter the console command, go show collision, you can see the collision box of the player, and you can see here. So if we change this vision distance to be 0, it's going to be right up against the capsule, which is fine. It doesn't throw any errors. We tell it to ignore the character, but I just have it pushed out just a little bit there, but you can see our vision is working just fine. And in the next episode, when we get our world items working, then we'll be able to see that our debug lines will turn green when we hit an object. Now this looks different than what you're used to when you're running the debug lines from blueprints. When you hit something, you get that little box that pops up where the hit location was at. This doesn't give us to it. I think there's, instead of draw debug line, I think there's a different one that we can do, but essentially the entire thing's just going to change color. That's why we had it, we gave it the debug value like we did, is so it's going to be red if we don't hit anything, or it's going to be all green if we're hitting anything within the range. It's just not going to show us that little box of the hit location of where it was at, which is fine with me. That works good. And with that, I hope you guys found this useful. If you did, please do me a favor, go down, hit that like button, subscribe if you haven't done so yet, hit that notification bell, be updated whenever we drop a new video. If you got any questions, drop them down in the comments. I'll answer them the best I can, or you can jump on over to the Discord, join the community over there, ask your question, and you'll get more than just me helping out over there, and you might get some new ideas, and who knows. Thanks for watching, and until the next one, peace.